Okay, this video is about solving systems of nonlinear equations. So before we do, I'm just going to remind you what a system of equations is. A system of equations means more than one equation. So where you've seen this before most likely is solving a system of linear equations. Something like if we had 3x minus 2y is 1 and 4x minus 7y is 3. If you had this, these are both linear equations where this is a line and this is a line. And so graphically it's easy to interpret these. If you graph this line, for instance, maybe it's that, and you graph this line, maybe it's that, and they intersect at this one point, then there's one coordinate, one set of coordinates, one x value and one y value that would solve both of these equations, this system, at the same time, and that's the solution. Another thing that could happen is you could graph this line, and then you could graph this line, and they would be parallel, and they would never intersect, and so there would be no solution in this case. So this one had one solution. This one has no solution. Or the third thing that could happen is you could graph the first line, and then you could graph the second line, and the second line would lie right exactly on top of the first line. So how many places are those guys touching? They're touching infinitely many places, and so this one has an infinitely many solutions. Other words you may have heard, this is called a dependent solution, and this one's called an independent solution. That's a linear system of equations. What we're going to be looking at is nonlinear, which means at least one of the equations is non-aligned. And so here is an example. Example 1, we could look at something like x squared plus y squared is equal to 100. And then we could look at this y minus x equals to 2. The fact that there's more than one equation at the same time, it makes it a system. And then the fact that this is not aligned, this is a circle, this is aligned, but one of them is not aligned makes it nonlinear. So let's just think about it. This is some type of a circle, and this is some type of a line. So here's the potential things that could happen. You could have a circle and a line that intersects the circle at two places, and that would give you two solutions. You could have a circle and a line that do not even touch each other. That would be no solutions. Or you could have a circle and a line that just hit it just at one place, tangent. It just touched it tangent, and that would yield one solution. That's the potential things that could happen in a scenario like this. If we look at this circle, this has the center, if you recall the standard form, x minus h squared plus y minus k squared is r squared. What we're looking at is a circle that's centered at the origin with a radius of 10 is what that is. So this would be the point, maybe 10, 0. It's 10 units out. This is a line, so I'm going to solve for y so we can see what that looks like. Y is equal to x plus 2. Y equals mx plus b. M, the slope is 1 over 1, and the y-intercept is 0, 2. So this is a line where you go up 2, up 1, right 1. It's going to intersect. I'm expecting, this is just a sketch, but I'm expecting two answers to this one. So let's go ahead and solve this guy. Let me erase, let me just rewrite it here. X squared plus y squared is 100. All right. And then we have y minus x is 2. Here's our system again. Back over here, if you recall in intermediate algebra when you learned how to solve a system of equations, you learned probably a few methods. One would be graphing it and seeing what happened, where do they intersect. Another one might be adding the equations together and trying to make one of your variables sum to 0. So if you did that, like you might, to get these to add to 0, if you chose x's, you might multiply the top equation maybe by -4 and the bottom equation by 3, and then you'd have a -12x plus a 12x, and that would sum to 0. That's called addition method or elimination method. That's a good method if you have terms that are like terms. When I look at this system, I have x squared and x, I have y squared and y. Those are not like terms. Those will not combine or add together. So elimination is a bad method. It would not be what I would choose for this one. The choice I would use for this would be substitution. That's where you solve for one variable and then substitute that expression in for the other variable. So that's what I'm going to choose to do. I'm going to look at this bottom. It looks real easy to solve for y, get y by itself. So I'm going to start with the second equation here and say, okay, y is equal to, I'm going to add x to both sides, x plus 2. All right, now what I'm going to do is substitute this expression for y into the first equation. So instead of saying x squared plus y squared, I'm going to say x squared plus, I'll use something besides green. I don't know how well that shows up. I think I have a blue. X squared plus x squared plus x plus 2 squared is equal to 100. All right, so now I'm going to square this term. This will be x squared plus x squared plus 4x plus 4 is what you get when you square that. Then I'll combine like terms. I have 2x squared plus 4x plus 4 is 100. And now I have a quadratic equation I need to solve. So the methods that we can use to solve a quadratic equation are by factoring, if it factors, by completing the square all the time, by, let's see, quadratic formula all the time, and then sometimes it's in a form where we can just simply take the square root of both sides. So let's get a 0 on one side, so that gives us 2x squared plus 4x. If I subtract 100 from both sides, I'll get minus 96. And then what I am allowed to do is divide both sides by a number. That's legal. What is not okay is divide both sides by x. You're never allowed to do that when you're solving an equation, because if you do that, you lose a solution. So I'm not going to do that. I'm going to divide by 2. And that gives me x squared plus 2x minus, I think it's 48. 2 goes into 96. 2 goes into 9 4 times. That's an 8. That's a 16. Yeah, 48. Okay, so I'm good with that. Now, so here we go. X squared plus 2x minus 48 is 0. I'm going to try to factor this. Ax squared plus bx plus c. I'm going to use the AC method of factoring. A times c, find the two things that add up to be b. So 1 times negative 48 is negative 48. I want to find two factors of 48 that would add together to become a 2. One has to be positive and one has to be negative. I think it's going to be 8 and 6. 8 times 6 is 48, and 8 plus negative 6 is 2, so that will work. Since the leading coefficient is 1, this factors straight into x plus 8. X minus 6 is 0. Set each factor equal to 0 using the zero product property, and we get x plus 8 is 0, or x is negative 8. X minus 6 is 0, or x is 6. How do we find the y coordinate that goes with this? We substitute this x value into this equation right here. So now we're going to take negative 8 and plug it back into here. So we'll get, when x is negative 8, y is negative 8 plus 2, or y is negative 6. Negative 8, negative 6 is one solution. When x is 6, y is going to equal to x plus 2, or 6 plus 2, 6 plus 2. And so when x is 6, y is 8. Let's look at the little sketch I drew. This point right here is the negative 8, negative 6 point. This point right here would be 6, 8. So that's one example of a nonlinear system of equations. I'm going to do one more example of this. And so let me erase all of this. That was a circle and a line. What about if we had maybe a circle and a circle? Let's look at that. What if we have a circle and a circle? X squared plus y squared is 25. And then we have 25x squared plus 16y squared is 400. oh, this is not a circle. I mean, this is a circle. It's the center is 0, 0, the radius is 5. This is an ellipse, which is kind of an oblong circle. So what are the situations you could have? You could have a circle and an ellipse. Okay, pretend like that's an ellipse, where they never intersected. You could have a circle and an ellipse where they intersected 4 times. You could have a circle and an ellipse where they intersected 2 times. You could have a circle and an ellipse where they intersected 1 time, 2 times, 4 times, 0 times. These are the scenarios I can kind of think of with a circle and an ellipse. So let's just see what would happen here. This is a system that I would try to solve using system of equations because, system of equations, addition method or elimination method, because like terms, x squared, y squared, y squared. So I'm going to try to eliminate a variable. So I'm going to choose x's to get rid of. And so how I'm going to do that is I'm going to multiply the top equation by negative 25. So if I do that, if I choose to multiply the top equation up here by negative 25, I'm going to have to do some multiplication. And I guess I will use my calculator to help me out. Negative 25. Okay, negative 25 times x squared is negative 25 x squared. And negative 25 times y squared is negative 25 y squared. And 25 times negative 25 is negative 625. Okay. And now we're going to add these equations together. This plus this is a big old 0. Negative 25 plus 16 is negative, I think it's 9. I'm going to double check because I'm not sure. Negative 25 plus 16 is negative 9. Okay, good. And then negative 625 plus 400 is negative 225. Now we'll divide both sides by negative 9, just to make sure I'm dividing right. So when we divide both sides by 9, we get y squared is 25. Okay, when you have a situation like this, y squared is 25, so now we can solve this quadratic equation by taking the square root of both sides. So this is going to equal to, you're going to say the square root of this is equal to plus or minus the square root of that. So the square root of y squared is just a y, is equal to plus or minus the square root of 25 plus or minus 5. So we got 2 answers. Y is 5 and y is negative 5. We have to plug each one of these in and solve for x. Let's go to the top equation here and use this answer. Okay, so right here, when y is 5, let's see what happens. And then when y is negative 5, let's see what happens. Okay, so when y is 5, let's see. When y is 5, we plug it in here. We get x squared plus y squared, or 25, is equal to 25. Subtract 25 from both sides, and we'll get x squared is 0. Take the square root of both sides. The square root of x squared is x, is equal to plus or minus the square root of 0. Plus or minus 0, which really doesn't make any sense, because 0 is not positive or negative. It's just 0. It doesn't hold a sign. So we get x is 0. What would happen over here? Let's look. X squared plus negative 5 y squared is 25. We get x squared plus 25 is 25. Subtract 25, x squared is 25, 0, sorry. X is plus or minus square root of 0. Oh, so we get this point. We get when x is 0, y is 5, 1 point. When x is 0, y is negative 5. So what we have here is, if we look, we have a point up here at 5, 0, 5, negative 5. This is the 2 places that our circle and our, this is our circle, and then our ellipse is, I think it's elongated this way. I'm not sure, I can't really think of how to draw this guy. But anyway, it's going to hit 2 places is what we have right there. There's our solution right there. Okay, maybe one real quick example. I'll try to I know it's a long video and it's hard to watch this long, but here's one last thing that could happen. What if you had a circle and a parabola? Let's have a look at that really, really quick. So, what if we've got this example right here? Y is x squared. That is a parabola. We know this is our basic parabola that is got the vertex at the origin. And 3x is equal to y plus 2. This is a line with a positive slope. So it's some kind of line like that. So maybe this will have two solutions. It could have no solutions or one solution, but we'll just see what happens here. This, again, do not use elimination. It'd be a hard way to go. What I'm going to do here is just solve for one variable and substitute it in. I'm going to solve for y and put it in for, I'm going to solve for y by itself. I'm going to get 3x minus 2 is y. I'm going to substitute this in for the y right there. So in the top equation, I get 3x minus 2 is equal to x squared. Have a quadratic equation. I'll get a 0 on one side. If I subtract 3x and I add 2, I get x squared minus 3x plus 2. I'm going to solve this. If I don't like my 0 on this side, I can move it over here. That is called the reflexive property of equality, and you're allowed to do that. I'm going to factor this fella. Let's see. AC is 2. They need to add up to be -3. -2 and -1 will do it. X squared minus 2 minus 1 is minus 3x plus 2. X is 2. X is 1. When x is 2, I'm going to plug this into here to see what happens for my y. 3 times x, which is 2, minus 2 is equal to y. So I get 6 minus 2 is y, or 4 is y. So that means when x is 2, y is 4. If x were 1, what would happen here? I'd have 3 times 1 minus 2 is y. 3 minus 2 is y. 1 is y. When x is 1, y is 1. Here are the two solutions that I get. This is maybe 2, 4, and this is 1, 1.